The days are getting shorter, and it's time to start taking tests. This is your first twin. This is twin 1 through 1.6. So do before you test. The day it says on here is probably not right. This is an old twin, so we'll see when you have a test. Maybe it's next Thursday, I don't know. Use the diagram below to answer questions 1 through 10. Alright, so first up, find each key feature of this function, its domain. Remember, domain, boys and girls, is your leftness to rightness, your x values. This graph starts when x is negative 11, alright, close to negative 11, and it runs all the way to 2, and we just jump. X is allowed to be 2, but x is not allowed, sorry, negative 2, but x is not allowed to be positive 2. So, parentheses on that. We jump to the other side of that positive 2, so union with 2, and we can just walk non-stop until we hit 11. So, there's the domain. Range is going to be your y values from the bottom to the top. This thing's got a heck of a gap here where there's no y values. But they start really close to negative 6. And then you can ride either side of this v. Now, if you ride this v, you can't actually get to a y value of 2. But if you ride this side of the v, you can get to a y value of 2. So 2 with a bracket. And then you make this jump up to this horizontal line, this constant line. And anywhere on that constant line, y has a value of 7. So negative 6, 2 union with 7. Increasing. Increasing means that we have positive slope. I'm going to type this out. It'd be a little easier on y'all. It would be easier if I typed it out. Alright, so we're looking for positive slope. Positive slope's going to happen right there. And I don't see anywhere else that we have positive slope. Now, the x values that make this true, they start close to 2, and they stop, looks like at a 6. So from 2 to 6, we have positive slope. All right, next up was probably decreasing. That means negative slope. It's going to be that interval right there. We are decreasing. We are going downhill. That part of the graph starts when x is roughly negative 2, and it stops when x is roughly positive 2. So from negative 2 to positive 2. All right, where the graph is positive. Positive means that I am above the x-axis. So this, and all of this. Now, this piece starts at negative 11, and it runs to 2, and it includes 2. So then we run to, looks like negative 1. So from negative 11 to negative 1, that graph is positive. And then there's that other segment which starts just past 5, and it stops when the x value gets right at 11. And we don't use brackets on anything other than domain and range. Negativity is up next. Negativity means below the x-axis. And there's actually 2 intervals on this one because there's nothing there. So from negative 1 all the way to 2, union with the other side of 2. So 2 from the right all the way to what, 5? Looks right. X-intercepts, I just did a video earlier today where I ranted about this. I don't get the issue, but there's one here, it's at negative 1, 0. There's another one there at 5, 0. I don't understand how a junior in high school cannot pick out an x-intercept. It blows my mind. And if you can't do it, you're not the first kid I've seen like that. You won't be the last. I just legit do not understand how you can't pick out an x-intercept. It's where you cross the x-axis. It's not rocket science. Y-intercepts. There is a y-intercept. It's right here. Remember, order of pairs, we talk about x first. So it's at 0, negative 2. My eyes are tired, but that looks right. All right, then we got average rate of change. I don't know why kids don't get slope either. I don't understand how you made it through middle school without understanding average rate of change. But it's from negative 3 to 0. So at negative 3, this is where you'd be on the graph. And that's what we do. We put a point on the graph. And when x is 0, this is where you'd be on the graph. And then we think about rise over run. All right? Rise over run. So we do. Remember, rise over run. Not a hard concept. Now we are falling. We're falling from 7 down to, looks like -2. So we fell 9 and we ran right 3. So it's -9/3, which is just -3. All right, next up is f of -2. That is saying what is y when or where x equals -2. And you know, this is one of those where you got a choice. You can either be the open hole or the closed hole. And you got to be the closed hole because there ain't nothing in an open hole. You got to be the closed dot, kids. And when you're there, the y value is 7. Oh, by the way, did you know that a middle-aged dad bod dude worked this out on YouTube? I did. It's there. Of course, you're probably watching it through the classroom. All right, the graph of y equals negative absolute value of x minus 3 plus 4 is reflected across the x-axis. What is the equation of the reflected graph? All right, now the function rule for an x-axis reflection. We'll call the new function g of x. It is negative f of x. That's what she is. So g of x would be where I take the whole function, I wrap it in a negative, and then I distribute that negative. I'd have negative absolute value of x minus 3 minus 4. Now, let me prove to you that's correct. I will be giving you calculators on the day of the test. Of course, I don't know what's going to happen with you. But what was the original equation here? Clear. And we'll have had just a touch of calculator experience by the time we take this test. So this won't be new. What was the original equation? Negative absolute value of x. I made a mistake. A negative times a negative is a positive. Alright, so we have negative math. Num, which is how you feel, ABS, x minus 3, and then we got what, plus a 4, zoom 6, like I've been telling kids for 15 years now, but they never listen to me. That's the original graph, all right? If I want to reflect it around about the x-axis, I expect this vertex, which is 4 units above, to be down here, and I expect it to open up. So a very common mistake is people only negate the first part. Like this is what a lot of kids would do, and this would be an answer choice. And it is a vertical reflection, but it is not an x-axis reflection. This would be an answer choice, and it would be dead wrong. I'm literally showing you that you can type answer choices into a TI-84 and be fine. What should have happened is we should have also negated the 4. And then you'll see your x-axis reflection. Some of you will, some of you won't. Some of you just don't even know what a reflection is. Some of you still like to say the word flip and think you're ready for college. You're not. Like, you're not maturing academically. There she is, an x-axis reflection. All right, over what interval is the graph of y equals -2 plus the absolute value of x plus 6 decreasing? So there's a couple of ways of doing this. Honest to God, it's probably quicker to graph, but I'll use f of b minus f of a as well. Let's look at this as the absolute value of x plus 6 minus 2. That is a shift left 6, 1, 2, 3, 4, 5, 6, and then down 2. And then your initial slope is the understood 1. So I am decreasing here. And honestly, that's probably the only way to do it. I didn't give you an actual numbers to plug in. But it is decreasing from negative infinity all the way up until you hit -6. Picture's worth 1,000 words, bruh. I guess you should learn how to graph. You could have looked at this in a calculator. I'm not saying you couldn't. But a picture is always worth 1,000 words. So that was a negative. Let's not modify the equation. -2. Notice I used the negative symbol, not the minus. plus math, num, ABS, x plus 6, graph. Let's do zoom 6. Not a good habit. And then maybe you could have seen it. Of course, it's hard for kids to look at things, but x is negative 6, decreasing is downhill from negative infinity all the way to negative 6 is where she is decreasing. Or, and hear me out because I might decide to use set builder, I don't know, all values of x such that x is less than negative 6. Who knows, might do set builder. 13, identify the transformations of the parent function f of x equals the absolute value of x and give g of x being negative 3 minus 2 absolute values of 3 times x plus 3. So what happened? First off, let's put that in a more apparent order. So let's rearrange. G of x is negative 2, absolute values of 3 times x plus 3, and then minus the 3. And I think I probably want verbal descriptions on this one. It'd be multiple select. So let's line up with the a, b, x minus h plus k idea. So I know that a is negative 2. What has that done? That is both a vertical stretch and a vertical reflection. It is not an x-axis reflection. We don't know that for sure. I know that b is 3. That is not a stretch. That is a horizontal compression. Factor here of 3, or a third, whatever you want to think. Let's see, what else we got? Let's say factor of a third, because it works opposite. Let's see, what else do we have? We have h being negative 3. That is a horizontal, let's use a big word, translation of left 3. And when I did my lineup process here, k was negative 3. That is a vertical translation down 3. Beautiful stuff. And then look at them big words, translation, horizontal, vertical. And still, 1 in 7 of you have no idea what it means to be vertical or horizontal. It's a shame. I don't understand it. Whatever. Anywho, moving forward. Graph the piecewise function. Think about the individual pieces. And evidently got something got cut off there. But that first line says y is negative 6. All right. You're supposed to know your mama functions. And if you want, we can do a table. It doesn't matter. You're going to feed it a negative 1 and a 2. And it's going to say negative 6. So negative 1, negative 6 would be solid. So back 1, fall 6. I don't like the grid I chose for this, but there it is. And 2, negative 6 would be open. There you go. Then we have 4. It showed up, 3. We have x, and then we have 4 minus x. We get to feed it a 2 and a 4. If we feed it a 2, 4 minus 2 is 2. If we feed it a 4, we get a 0. So 2, 2 exists on the graph, and it is solid. And 4, 0 exists on the graph, and it is also solid. All right, next we have 3, this guy right here. Y is 3. And I'm saying this, but and the truth is, like so many of y'all miss that. That's horizontal. And you know, if you need a table, whatever, like I'm willing to work with you. But you probably don't understand the table anyways. You can feed it a 4, you can feed it a 5, and you can go on forever until you hit infinity. But anywhere on that thing, you're going to have a value of 3. It's open at the 4, and then it just runs to the right forever. And there is that piece function. It's much like trauma, running to infinity. It is forever. 15, write the equation for the piecewise function shown. So another one. This one is not too bad. You should view this as what she is. This is x squared. This looks like y equals 5. And this guy right here, if you think about mx plus b, which is slope-intercept form, is 1/2 x plus nothing. We won't say plus 0. So when we write the piecewise function, there's your 3 pieces. Now I usually do domain first, but this one was so easy I just went ahead and did it. X squared 5 and 1/2 x. And we're not going to say plus 0. And you got your if statements. So this part of the parabola is drawn from -infinity to 0. And if you don't see the dot, it's understood to be closed. So -infinity to 0, or x is less than or equal to 0. This piece is drawn between 0 and 2, non-inclusive, 0 less than x less than 2. And this piece would have the solid dot. It's drawn from 2 to infinity, or x is greater than or equal to 2. Usually one of those has equality. And I just forgot to put the solid dots on this graph, but if you don't see the solid dot, it's understood that there is a solid dot. Alright, 16, which of the following are arithmetic? So, day one on arithmetic, nobody except Ryland had any idea what arithmetic was. He was the only kid who knew what it was. But arithmetic is adding or subtracting. Now, to be an arithmetic sequence adds or subtracts a common difference. All right? So, I know some of us are arithmetically challenged here. So, if you're a button pusher, bless you. But if you don't know what the difference between 1 and -5 is, you have to do -5 minus 1. And I bet you get 6. And if you don't know what the difference between -5 and -8 is, you have to do -8 minus minus 5. Or minus a -5. I'm somewhere else. Where did my negative symbol go? -5. And it's a -3. So there is no common difference. All right. On this one, the difference between 9 and -10 is going to be 19. We are adding 19. Plus 19. And we do it again. Oh, sorry, not plus 19. Take away 19. We take away 19. So yes, D equals -19. Definitely arithmetic. Ruh-roh, there are fractions. There are fractions. So this might be where you decide to push buttons. Because bless you. How far apart are a half and a quarter? Figure out what a half take away a quarter is. And by golly, it's going to be probably 0.25. Then you need to see how far apart 3/4 and a half are. And I bet it's 0.25. I bet it is. Do you want to see? Are you curious? It is. So this dude right here, yes, D, I wrote DDE, I'm tired. D is 1/4, 0.25, okay? All right, then we got some more fractions here. We got 1, 5, 6, 2/3, 1/2. So I know that the difference between those two is a 1/6. And, I'm old school. Like when I see 2/3, I'm also thinking 4/6. Again, the difference is 1/6. When I see a half, I'm also thinking 3/6. The difference is 1/6. But you can push buttons too, right? Like you can do 5/6 minus 1 and 2/3 minus 1. And by the way, it was going downhill. So it's all negative, which is fine. You're subtracting a 1/6. All right, write the explicit form of the arithmetic sequence 2, -7, -16, -25. What is the difference? Now, let's start off with the form of an arithmetic sequence is simply a sub n. I need to use subscripts here. A subscript n equals a sub 1 plus parentheses n minus 1 times d. So I got to pick out the stuff, right? That's all I really got to do. Pick out the stuff I need, which is easier said than done. I blame social promotion. The difference is lose 9. -7 take away 9. By God, it's -16. -16 take away -5. So I know that D is -9. And the first term is obviously 2. So I'm just going to plug stuff into that thing, and I'm going to write a rule. That's all it's saying is give me the explicit rule. Don't be surprised if you see negative 9n in the rule. Maybe you'll make that connection. Anyways, a sub n is going to be 2 plus. Remember I said you could put the d out front? Made a joke about it in class. Completely inappropriate, but I did it anyways. We have 2 minus 9n, because we're using the distributive property, and then we're going to combine like terms. 9 plus 2 is 11. We want mx plus b form because these are equations of, do you remember? What are their equations of? If you said lines, bingo, you got it. If you didn't know, pay attention in class. Mx plus b is where it's at. It looks like a line. And there you go. That's your equation. Easy peasy lemon squeezy. Alright, write the first 4 terms of the sequence defined by a sub n is blah blah blah. So you're expected that you remember the general layout of a recursive rule. The general layout is that you have a sub 1 if n is 1, and then a sub n minus 1, which means the previous term, plus the common difference if n is bigger than 1. So, don't be the kid. The first term is 12. And I'll have an answer choice where the first term is not what the thing says, and it will get picked. Ugh. Now, the pattern was add 3, right? So you got to do 12 plus 3, which shall be 15. And if you add 3 again, you shall be 18. And if you add 3 again, you shall be 21. Find the sum of the arithmetic sequence 33, 22, 11, 0, negative 11, dot, 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 negative 99. Now, this problem will probably be about half done recursively. I would say roughly half will do recursively. Actually, it'd probably be closer to 2/3, because it's not a bad sequence, right? Like 33, 22, 11, 0, negative 11, negative 22, negative 33, negative 44, negative 55, negative 66, negative 77, negative 88, negative 99. I mean, you just add all terms. It didn't take me that long to finish the sequence, okay? Whatever that is. I don't feel like doing that. I like math. Speaking of which, I literally just told you how many terms there were. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 13 terms. Where am I going with this? Why am I talking about this? Well, there's a formula for this. Of course, you wrote it out. But the sum of n things is n over 2 times the first term plus the last term. Okay? Now, there happen to be 13 things. And let me show you how to figure out how many things there are without drawing it out. Okay? So, say I did not know, or I didn't draw it out. I didn't want to do it recursively. I want to do it explicitly. I would use this guy. A sub n is a sub 1 plus n minus 1 times d. The last term is negative 99. The first term is 33. The difference is lose 11. So I would invoke the distributive property. I would subtract 33. Negative 99 minus 33 is what? Negative 132. I feel pretty good about that. That would be equal to a negative 11n plus 11. I'd have to take away 11 more. I'd get negative 143 equals negative 11n, and then I would divide through out by 11. A negative 11 at that. And I should get 13. And I do. Hold on, I'm recording. Let me pause. Alright, sorry for the interruption there. Anyways, that is how you do it explicitly. This thing only had so many terms. Like, I'd be hard pressed to do it explicitly. But, that being said, yeah, I'm teaching math here. So the sum of 13 things is going to be 13 over 2 times the first term, which was given, as was the last term, 33 plus a negative 99. So the sum of 13 things is going to be 13 over 2. This is going to be negative 66. If we cut a negative 66 in half, we would have a negative 33. And then we got a pretty good sized number, right? We have negative 330 plus a negative 99, which is negative 429. Seems right. I don't know. Check me on that. Okay, I don't feel like going back and double checking it. I feel pretty good about it. Yeah. I feel good about it. All right, moving on to 20. I would not do 20 recursively. The reason I wouldn't do 20 recursively is because there are 22 rows. Now, it's doable. You're supposed to figure out how many chairs there are. I mean, you could sit here and you could say 48 in the first, 52, 56, 60. It wouldn't take all that long, would it? It wouldn't. It wouldn't. But let's see, let's talk about Gauss's little formula. Let's see what we know, okay? I know the first term is 48. There are 22 rows, so I know n. So I'm finding the sum of 22 things. It's 22 over 2. And then I have 48 plus the last one. And I don't know the last row, but it's easy to get the last row because there's a formula for a sub n. It says a sub n is a sub 1 plus n minus 1 times d. Now, since I want the last row, I actually want a sub 22. So I know what n is, okay? The first row was 48, n was 22, and the difference was 4. So the 22nd row is going to be 48 plus 21 times a 4, which is 48 plus, what, 84? Which is 136. No, 132. And I can put that right there. And then I can do some math, right? 48 and 132, I think that's 180. We got the 22 over 2. And by all means, push buttons. We'll check myself on this one. Half of 180 is 90. It's 1800. Should be 1980. You know, let's just check me. Let's just type this in, see what it is. But it should be 1980 chairs. Big theater. So we had a 22 over 2. Actually, let's just do this proper. Math, num, n over d. Let's get this out of the way. We had a 22 over a 2. Set of parentheses. We had 48 plus 132. And was Milbrath right? Milbrath was right, 1980 chairs. Moving forward, use the graph to solve 1/2 the absolute value of x minus 1 plus 3 is equal to the absolute value of x. Now remember, you do these things separately. You have two equations. One of them is y equals 1/2 the absolute value of x minus 1 plus 3, and the other one's y equals the absolute value of x, which happens to be the mom function. So let's do the easy one first, which is the absolute value of x. Lots of dots because we want nice intersections, right? You guys should be champs at this. You should be champs at this. Doesn't mean you will be. Write 1 up 3. Rise 1, run 2. Rise 1, run 2. I need to change colors here. There's that one. It's over there. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. So I would say that this one's happening at, what is that? That's -5, probably -7 back here. It's a bad grid. The other one is at 5. Let's just check that real quick. If I throw in a -7, this becomes what? -8. The absolute value of -8 is 4. The absolute value of -8 is 8. Half of 8 is 4. 4 plus 3 is 7. If I plug in -7 right there, that becomes as well. So I've checked it. They both work. Sweet. Moving forward. 22. Solve the system of equations algebraically. You can use substitution. You can use elimination. You can use the transitive property. But you can't graph. It's about algebra. Now I'm going to do the elimination method. In the elimination method, you multiply one or both equations so that you can add them together and a variable disappears. So I am going to multiply the bottom equation by a negative 2. And if I do that, I'll have negative 2x plus 2y equal to, was that 16? Negative 32. And then I'm just going to add down. That way the x's are gone. 6 and 2 is 8. 12 and negative 32 is negative 20. And I got a fraction. Oh, man. When I was a kid, this was an idea that you made a mistake, but I just make stuff up. And the truth is, since the advent of calculators, we really don't care if there's fractions or not. Just making sure I didn't do anything wrong. I don't think I did. Divide out the 8, and I'm going to get negative 10/4. Now, I know what y is. How do I find x? Well, there's this equation right here. This would be x minus a negative 10/4 is equal to 16. So x plus 10/4 is 16. Now don't be scared. On the test I'll probably have nice numbers. Probably. Going old school by hand, we would do 16 as 64/4 minus 10/4, and we would get 54/4, which is 27/2. So order pair here is 27/2, negative 10/4. Now, you know, if you can't do the math in your head there, I mean, you can just type in a calculator 16 minus 10/4, which I should have reduced to, I don't know why I didn't do it. I need to fix that. Should reduce that down to 5/2, right? And I will. 13.5, math, enter, 27/2. And by the way, I should not have left that as negative 10/4. I'm judging myself harshly. That is negative 5/2. I was a little curious about that one. I thought this one came out with whole numbers. So let's just check myself real quick. Be nice if you could do this on test day, wouldn't it? There are some schools that teach like purely through Desmos, like they've almost quit teaching algebra because, you know, their students are really bad. So they just do this. And then that kid goes to college and they're woefully unprepared. But they are learning the power of graphs. They are. Alright, so let's see here. 13.5, negative 2.5. That's exactly what I have, because I have 27/2 and negative 5/2. So, yeah, we're good. Moving forward now, down to 23, which is a use tech. So in this case, that means use your TI-84. So let me give you a recap what you're going to do here. You're going to place the left-hand side into Y1. You're going to place the right-hand side into Y2. You're going to hit zoom 6. You're going to hit second trace intersect. All right. That's how you're going to do this thing. So the left-hand side is negative 3 absolute values, math, num, ABS, x plus a 2, get out absolute value, plus a 3. The right-hand side is a quarter. I'm just going to go ahead and leave that wrapped like I wrote it, of x to the second minus what? 3. And then I get to hit that zoom 6 button. Zoom 6. And let's see how many answers this bad boy has. She has 2. Yeah, there's one here and one there. That one's pretty easy. Like x is obviously 0, right? Let's just make sure. Second trace 5. I always like to go after the left intersection because we're supposed to read from left to right. So I just pressed that left arrow until I got close. Then enter once, twice, thrice. So negative 3.1652, because I'm asking you to round to the nearest 10,000th probably. Let's see, let's just snip this, put it on the grid here. It says nearest 10,000ths, yeah, that's 4 decimal places. There is another intersection, second trace 5. I'm going to hold that right arrow down until I get close to the intersection. I'm pretty sure it's 0, but I could be wrong. I'm glad I checked. Okay, so this is funny. You're going to see this sometimes. That's scientific notation, worth talking about. Not every example I do is going to come up with that. So, what are our answers here? Well, this one, if we round to the nearest 10,000ths, which, by the way, dum-dum, is the 4th decimal place, is negative 3.1651. Oh, 2, because after that 1 is a 5. That makes you round up. Now, see how this one's written? That is 4.247 times 10 to the negative 14th power. Okay? That means move the decimal left 14 places. It is essentially 0. This is a rounding error in the calculator. That's what it is. It's a rounding error. So when I get to this one, I'm just going to call it 0. I'm not rounding it. It's a legit mistake that the calculator makes. X is 0. And you may or may not have it. Your calculator may or may not do the same thing. It's kind of interesting. It's because I think they use a technique called Newton's method to do this. So I could see that there might be a glitch here and there using that technique. But I don't know. I did not write the algorithm or the code for the TI-84. So I can't tell you why it has that glitch, but it does have that glitch. Alright, graph f of x being the square root of 36x minus 72 plus 5. And we're going to do a little factoring first. We're going to pull a 36 from the inside and make that 36 times x minus 2 on the inside and then plus 5. We're going to take the square root of 36 and we're going to get a 6. So 6 square roots of x minus 2 plus 5. Now you're supposed to know that mama is an arm and the kid's going to be an arm. And the kid is right 2 and then up 5. And the kid has a slope of 6, so we have to rise 6. 1, 2, 3, 4, 5, 6 as we run right 1. And it's going to be an arm. Actually, it looks kind of like a logarithm the way I drew it, but it's supposed to be an arm. 25, graph f of x equals x squared minus 7x plus 12. So there's a couple of things you need to know. The x coordinate of the vertex. This is tomorrow's lesson. Today's Wednesday. I'm planning on doing this lesson on Thursday. Is opposite b over 2a. To find the y-coordinate of the vertex, what we technically do is we find f of opposite b over 2a. And I know some of us are functionally challenged here. That means plug x in. Okay? Other things. To find x-intercepts, let y equal 0. And to find y-intercepts, we let x equal 0. So there's a lot of little nitty-gritty stuff going on this one to do it by hand, which means a lot of us just won't do it, which is fine. Nobody said you had to pass. Passing in high school is not something that is given. Sometimes you have to fail to succeed. Now, the vertex on this one's going to be kind of rough because it's got some fractions. So if we do the x coordinate of the vertex, we're going to do opposite b over 2a. This a is 1, b is negative 7, and c is 12. We don't need c today. Opposite of a negative 7 is a positive 7 over twice a 1. And we get 7 halves, which is 3.5, right? To find the y-coordinate of the vertex, we take that and we plug it back in. Now you're going to have a TI-84 on you, so you may as well just do it like this with decimals. I'll try and make the test with easier numbers. I'll double check it and make sure it's fine. This is a practice sheet. I always figured if the practice sheet was a little harder than the test, we'd be okay. I might be wrong on that. I think it makes some kids want to quit and die. But, like I said, my job is to prep you for the next class. So I just plugged it in and I got negative 0.25, which, is negative 1/4. So I know where the vertex is now. The vertex is to the right 3.5 units and then down 1/4 of a unit. It's right there. As close as I can get on freehand graph. If I want the x-intercepts, I let y be 0. So 0 equals x squared minus 7x plus 12, which by God factors. Factors is x minus 3 times x minus 4. I use what's called the ZPP, 0 equals x minus 3 or 0 equals x minus 4. So x is 3 or x equals 4. And this is honestly enough to draw the graph. But if you want the y-intercept, it's super easy. By the way, the vertex also contains the line of symmetry, which is why it's kind of nice to find the y-intercept, because you only need 3 points to draw a parabola, okay? The y-intercept happens when x is 0, so it'd be 0 squared minus 7 zeros plus 12. 3, 4, 5, 6. So that's just going to be 12. What was I at? 6, 7, 8, 9, 10, 11, 12. And then I can use what's called symmetry. I have a point that is 3.5 units to the left of the line of symmetry, which means there is another point which is 3.5 units to the right. 1, 2, 3.5. Okay, so we're good. It would be right there. So if you don't want to do these 2 points, do those 2 points using the concept of symmetry. Or do them all, right? Collect the whole set. And that is it for the actual quiz. Up next is bonuses. I think I've got 8 minutes. I don't know if I can do all these bonuses in 8 minutes. Maybe I can. All right, what are the real solutions to the equation x to the 2/3 minus 1 equals x to the 1/3? All right. So real solutions would be on a graph. That's where they'd be. So check this out. Graphs are real. X to the 2/3 minus a 1 equals x to the 1/3. So we're taking the cubic root and squaring it and then taking away 1. And here we're just taking the cubic root of x. So the graphs are going to look kind of funny. If you cube the cubic root, it does something like this. It just makes everything positive. So here is the cubing of the cubic root. You'll notice that it's going to stay positive instead of this guy being down in negative territory. It's always increasing left and right. Well, anyways, it flipped it to some degree on this side. And I only want the real solutions. And there happen to be 2. So second trace 5. Of course, I got a hunch that the answers are probably radicals. There's one of them, negative 2.36. Now, I forgot that these came from a math contest real quick. But there are 2 real solutions. So let's do the algebra behind this. What we're going to do is we're going to set it equal to 0. X to the 2/3 minus x to the 1/3 minus 1 is nothing. Okay. This has to be done with the quadratic formula. We're going to think of this as u squared minus u minus 1. What I'm letting happening here is I'm letting u be x to the 1/3. If you square it, you get x to the 2/3. A is 1, B is negative 1, and C is negative 1. And then I'm going to sing a song. X equals negative b plus or minus square root b squared minus 4ac all over 2a. I'm going to feed this thing. So x is negative b, so opposite of a negative 1 is positive 1, plus or minus square root of a negative 1 that is squared, minus 4 times an a, which is a 1, times a c, which is a negative 1, all sitting pretty over twice a 1. Interesting, huh? 1 plus or minus square root. 1 squared is 1. Negative 4 times negative 1 is 4. 1 plus 4 is 5, all over 2. Now here's the fun part. This is, I'm saying x, but it was actually u. This is u. Remember, u is x to the 1/3. So x to the 1/3 is 1 plus or minus the square root of 5 over 2. Which means that x is this stuff cubed. What I would do if there are radicals in here is I would compare the decimals to the answers that are present. Alright, 15. The graph displayed shows the graph of a parabola with intercepts as labeled. What is the equation of the parabola? Okay, we can do this. I believe we can do this. There's a form out there called intercept form. It's y equals a times x minus p times x minus q. And this is p and this is q. So I can say that I have some a times x minus a negative 1 times x minus a 3, which is y equals a times x plus 1 times x minus 3. Now I need a. That's where this comes into play. That gives you an x and y. I can plug that in. If I see a y, I'm a negative 2. If I see an x, I'm a 0. Okay, this is going to create a 1, that's a negative 3, so negative 2 equals negative a times 3. Do some division, a is going to be 2/3. So I have the equation y equals 2/3 of x plus 1 times x minus 3. Now, there might be more to this. You might need to put it in standard form. You might have to FOIL. I don't know. A little low on time. I've got about 3 minutes till the next class. Which of the following expressions are equivalent to x squared plus 5x plus 6 over x squared plus 2x minus 3 divided by that? None of this stuff is not in